All right, in this section we're going to be learning how to solve exponential equations. There are several types of exponential equations that we're going to be looking at, and one type, or the first type, is going to be looking at exponential equations that have the same base value. The base is the number that you are raising to an exponent. So the 3 is the base here, 3 is the base here. Now if you have an equation, that means the left side of your equation has to equal the right side. And if the bases are the same, that also means that your exponents must be equal. So therefore, we can just write the equation where the exponent on the left is equal to the exponent on the right, and then solve for x. All right, so we're going to subtract x, giving us x, add the 4, which will make that equal to 6. Therefore, x is equal to 6 in this situation. Now on the next problem, it's a little bit different because your base values are not the same on these two problems. However, we can do a little manipulation to get the same base values. 8 can be rewritten as, let me write this down first. 8 can be rewritten as 2 raised to the third power. Now the properties of exponents say that when we have parentheses here, you're going to multiply your exponents together. So we're going to multiply 3 times that exponent, which will give us 2 raised to the 3x minus 1 equals 2 raised to the 6x plus 15. We now have the same base, which means the exponents are equal, so that means 3x minus 1 is equal to 6x plus 15. We can subtract 3x to bring it over here. That will become 3x. And we can subtract 15 to move it over here. That will make this negative 16. And then dividing gives us x is equal to negative 16 over 3. All right, so the next problem, again, we do not have the same base value, but we can get our base values to be a 5 by different means here. 1/5 can be written as 5 raised to the negative 1 power, and then raised to the x. 25 is equal to 5 raised to the second power. Multiplying the exponents on the left will give you 5 raised to the negative x. On the right, that'll give us 5 raised to the 2x minus 16. We now have the same base value, which means this exponent has to equal this exponent. So negative x is equal to 2x minus 16. We're going to add this x over to this side, which will give us 3x. And then we're going to add 16 over to this side, which will give us 16. And that leaves us with x is equal to positive 16 over 3. All right, so we want to work through a few problems here. And so what I would suggest is that you pause the video right now, write these problems down, and then try working through them. And then when you're finished, unpause the video, and then you can see the results for these problems. All right, welcome back. And so as you can see, we have all the work shown here, along with the answers that are written in red. Most of these are pretty standard. 16, we're breaking it down to a base value of 2 raised to the 4th power. 8 is broken down in 2 raised to the 3rd power. And that gives us these exponents. Solving for x, you're going to subtract 4x over to this side, and then you're going to add 3 over to this side, and that gives us x equals 15 over 2. Over here, remember that a radical is going to give us a fraction for an exponent. Square roots are the same thing as 1/2 power, and so this becomes 6 raised to the 1/2 raised to the x minus 7. 216 is equivalent to 6 to the 3rd power. Multiplying your exponents gives us this, and setting them equal gives us this. So what we can do here is we can make this easier to solve by multiplying this whole equation by your least common denominator of 2. All right, so when you multiply 2 times the first one, that gives you x. 2 times the second term is minus 7. 2 times these gives us this. Now we can solve for x. So subtracting x gives us 5x. Subtracting 18 gives us negative 25, giving us x is equal to negative 5. All right, so what's going to be a little bit different about these problems is we have an exponential equation where we have a base value raised to an exponent is equal to, and then some number over here. So this is an exponential equation. The variable is in the exponent. That's what makes it an exponential equation. And so once we have this written as an exponential equation, 8 raised to the 2x plus 3 equals the number over here, we can convert this to a logarithmic equation. And the reason we want to do that is because logarithms are inverses of exponential equations. And so that's how you solve, is by using inverses. All right, so we can convert this, which would be log base 8 of 1,000 is equal to 2x plus 3. All right, so this is your base value, which is the base value on the logarithm. 1,000, that's going to go over here. And then your logarithm is an exponent, which means it's equal to the exponent. And that's what this is right here. All right, so your last 2 steps then are going to be subtracting 3 to move it over here, and then dividing the whole thing by 2. All right, so what that's going to give us then is log base 8 of 1,000, and then minus 3 from that, and then divide the whole thing by 2. That's going to give us x here. Now, this right here, this can actually be written a couple ways. One way is to put the minus 3 right here, but you cannot subtract this 3 from the 1,000. You cannot do that because the 1,000 is part of this logarithm. If you want to help your notation by clarifying that, we can always put the negative 3 first and call it negative 3 plus log base 8 of 1,000 over 2. This would be the same thing as this up here. All right. So now this next problem, we've got several things in here. 2 times 3 raised to this power plus 4 equals 20. This is the format that we want to get our equations in. We want something raised to a power equals a number over here. That can be then converted to this right here. So we've got a couple of extra things here. This is your exponential part, the 3 raised to the x minus 1, which means we need to move this 2 to the other side, and we need to move the 4 to the other side. And when you are solving equations, you're going to be moving your addition and subtraction part first. All right, so that means we're going to move the 4 first. That's going to give us 2 times 3 raised to the x minus 1 equals 16. We now move the 2, and you move the 2 by dividing it. See, now we are down to the same kind of thing we had right here. So we are in this format of something raised to a power equals a number over here. We can convert this to a logarithm, which would be log base 3 of 8 is equal to x minus 1. And then you solve for x by adding 1 over to the other side. And that makes it 1 plus log base 3 of 8. All right, so just doing a little bit more practice here. The next problem, we're going to start out by adding 6 over to the other side. Now we can convert this to a logarithm. So it's log base 5 of 18 equals 2x plus 1. And then we'll finish this out by subtracting 1 and then dividing the whole thing by 2. All right, so that's going to be negative 1 plus this logarithm divided by 2 is equal to x. All right, so the next problem, we want to isolate this part, which means we need to move the 3 and the 1/4. This is your subtraction and addition part, so we're going to move this first. All right, so that's going to give us 1/4 times 2 raised to the 4x minus 5 is equal to 7. We now move 1/4 over to the other side by multiplying by 4. So you multiply by the reciprocal when you have a fraction. All right, so multiplying by 4 is 28. We now convert this to a logarithm. So this is log base 2 of 28 equals 4x minus 5. And we can finish this out by adding 5 over to this side and then dividing the whole thing by 4. So that's going to give us 5 plus log base 2 of 28. And all this is divided by 4. Now this next problem is a little bit different in that we have e in these two problems down here, but we still use the same procedure. So we would convert this into a logarithm, which will be log base e of 4 is equal to x. But we need to remember that log base e is not what we use when we have a base e. When you have log base e, you write it as natural log, because that is the definition of a natural log. It's log base e. And that's all there is to it. That is our answer, is natural log of 4. All right, so the next one, we need to isolate the exponential part, e to the x. That is our exponential part. And so we're going to add 14 over to the other side first. That's 25. Now 3 is not being raised to this exponent. So 3 is not part of the exponential part. We need to move it to the other side. Since there's multiplication in between here, we move it by dividing. And now converting, you're going to have log base e of 25 over 3 is equal to x. But log base e, we don't write it as that. We use natural log. So just get used to doing that. And so let me just go ahead and rewrite this whole thing as a natural log. So that's going to give us natural log of 25 over 3 is equal to x. All right, go ahead and write these last two problems down here and pause the video, work through them, and then unpause and come back and check your solutions. All right, so here are your solutions. Remember to reduce your fractions. And then since this problem had e as a base value, that means you're going to have natural log in your answer. This did not have e as a base value, and therefore you have a common log as an answer. All right, so let's move on to the last type of problem that we're going to discuss. And this is when you have an exponential expression, so a number raised to an exponent that has a variable, equals a number raised to an exponent that has a variable. So it's an exponential expression equals an exponential expression. These look similar to the very first problems that we were doing. However, what we were doing in those problems was getting a common base. And we wanted to get a common base so that we could just set the exponents equal to each other. Now, that is not always possible. So, for example, if you look at this problem, you have 5 for a base value and 4 for a base value. It is not possible to make these be the same base. So we're going to use a different method for this. Now remember that when solving equations, you can do pretty much anything to the equation as long as you do the same thing to both sides. All right, so what I'm going to do with this, when we have this situation, is I'm going to put natural log of both sides. And really you can use common log or natural log. I just prefer using natural log. Now the reason for doing this is, remember, our ultimate goal is to find out what does x equal. Now in order to find out what x equals, we've got to get x out of this exponent. And that's where the logarithms come in, because one of the properties of logarithms with the exponents is that we can move the exponent, this right here, we can move it to the front of the logarithm. That's the exponent rule on that. So when we do that, that is going to give us 3x minus 5 multiplied by the natural log of 5 equals x plus 6 multiplied by the natural log of 4. Now remember that natural log of 5 is just simply a number. It's going to be a decimal value, but it's just a number. So if you have a number, let's say that this number was 10, and you have 10 next to these parentheses. Remember, all that you're going to do is you just are going to distribute. So that's what we're going to do with this natural log. We're going to distribute it to both of these numbers here. All right, so that will give us 3x natural log of 5 minus 5 natural log of 5. And we'll do the same thing on this side of the equation, which will give us x natural log of 4 plus 6 natural log of 4. Now in solving equations, when you have x's on both sides of your equations, your next step is to bring your x's over to the same side. Everything that does not have an x goes to the other side. All right, so that's what we're going to do with this problem. We're going to subtract this over to this side of our equation. And that is going to give us 3x natural log of 5 minus x natural log of 4. Now, this does not have an x in it, so we're going to move it to the other side by adding it. All right, so that gives us equals 6 natural log 4 plus 5 natural log 5. Now, both of these terms have an x in them, so what we can do here is we will factor out that x out of those two terms. So that's going to leave you this first term with 3 natural log 5 minus natural log 4 equals all this stuff on this side of our equation. All right, so the next thing, well, we got to solve for x. We're down to just a single x here. The operation in between here is multiplication, so we can move this whole parenthesis to the other side by simply dividing by that parenthesis. All right, so what that gives us then for our final answer is x equals 6 natural log 4 plus 5 natural log 5 over 3 natural log 5 minus natural log 4. And that's how we are going to leave our answer. All right, let's do one more problem with this here together. So we have the same situation that we had before, something raised to a variable, something raised to a variable. We're going to take the natural log of both sides of our equation, which allows us to bring the exponent to the front. All right, so that gives us 5x plus 1 times natural log of 2 equals 2x minus 4 times the natural log of 3. Distributing is 5x natural log of 2 plus 1 times the natural log of 2 equals 2x natural log 3 minus 4 natural log 3. All right, so now we need to move our x terms to one side, and then natural log of 2 will move over to this side. All right, so that's going to give us 5x natural log 2 minus 2x natural log 3 equals negative 4 natural log 3 minus natural log 2. Factor out our common value of x, which leaves you with 5 natural log 2 minus 2 natural log 3 equals this stuff over on the right. And then we'll divide by the parenthesis, giving you negative 4 natural log 3 minus natural log 2 divided by 5 natural log 2 minus 2 natural log 3. All right, so what I want you to do now is I want you to pause this video, write this problem down, and work it out, and then unpause it, and then you can work through and see the solution that I have up here. All right, so go ahead and pause your video now. All right, so welcome back, and you can just follow through with the problem. Hopefully I wrote it out clearly enough, and this is your solution to this. If you have any questions, you can see me in the morning, or you can see me during class and ask at that time. Thank you.